Hello, welcome to my presentation. Today I'm going to present my statistics final project in distribution data about Celsius crypto. But before I jump into the main topic, first I'm going to introduce myself. My name is Michel Kristaya with the student ID number of 123210103 and I'm from class H. So before we jump into our main topic, I'm going to read the quote first. There's a quote from Thomas Sowell that say, "One of first things taught in introductory statistics textbooks is that correlation is not causation. It is also one of the first things forgotten." And here I also provide the data link. So I provide two links, which is the original data links and then the filtered data links, which is the below one. I also will provide the links and Spada. So in my presentation, I have four main points that I'm going to present. The first one is data distribution analysis. The second one is statistics question. The third one is sampling distribution, confidence interval, and hypothesis testing. The fourth one is regression and correlation analysis. What are the data used in this project? So the data that I'm going to use in this project, there are three, which is date, high value, and fallen value. So what is data distribution? Data distribution is a listing or function which shows all the possible values or interval of the data. So as you can see here, I provide descriptive analysis table for both of the high value and the fallen value. So here I provide mean, median, mode, standard deviation, range, minimum, maximum, sum, and count of each value or variable. And next I'm going to present the high value group distribution table, which I can see in my slide, which has interval of 0.017 and the quantity of the class are 10. And next, here is our the charts of the previous group distribution table. We have histogram chart, polygon chart, and the pie chart. Next is the fallen value group distribution table, which I had the cost interval of 47,000, and there are 10 classes in this value. And the same as before, I also provide the chart for the group distribution table, which is histogram chart, polygon, and pie chart. And next, I'm going to discuss about skewness and kurtosis. Skewness is a measure of symmetry, or more precisely, the lack of symmetry formula. So for the formula is, as we can see here, the skewness equals to 1 divided by the total of the data, which is the population, and then sigma from 1 to the number of the max population, and it is in bracket. It will be part of by 3, and then inside the bracket we have the current data subtracted with the mean and then divided by the standard deviation. And then for kurtosis we have, which is a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. So the formula is as it follows. It's almost the same as the skewness, but instead of parted by 3, the kurtosis is parted by 4. And here we're going to talk about more about skewness. Here there are skewness conditions, which there are 3 of them. The first one is if the skewness is 0 or it is really close to 0, then it is a symmetric normal distribution, and it will be as close as symmetric. It will look like a perfect bell-shaped normal distribution. And the second one is the skewness is positive number or more than 0, Then the normal distribution shape will be asymmetric or right skewed. And the third one is skewness less than zero or has a negative value, where the shape will be asymmetric or left skewed. And now we're going to talk about the high distribution. And we're going to examine for each height and volume distribution for the skewness. And I'm going to present the normal distribution of each value as well. First, for the high distribution, I have the mean, which is 0.07472, and the median is 0.06275. The standard deviation is 0.03745, and the skewness is 1.20387. So, so I got the skewness from the previous formula. I counted it and I got the skewness is positive or more than zero. Therefore, the graph is asymmetric or right skewed. As you can see here, that the normal distribution here is like uh, right skewed, where the right side of the normal distribution is like skewed on the right side right here. And then next we have volume distribution. I have the mean, median, standard deviation, and skewness. For the skewness, I got the number of 3.3619. So the skewness is positive or more than zero. Therefore, the graph is asymmetric and right skewed. So the same as before. As you can see, the normal distribution here, there's like the normal distribution shape is right skewed, as you can see here. And then I also provide some statistics questions, which are: what is the standard error of the mean? What is the confidence interval? And if we have a confidence level of 95%, and what is the correlation between both of variables, which is both correlation and regression analysis. And all of these questions I'm going to answer later and as the presentation goes. Now we arrive at the sampling distribution. So sampling distribution is a probability distribution for a certain statistic based on many random samples from a single population. And it is also the distribution of frequencies of a range of different outcomes that could possibly occur for a statistic of population. So we're going to talk the standard error of the mean. Standard error of the mean gives a measure of the variability from sample to sample, and and the formula is as follows. And then we're going to jump into the case. Say that X is a population of high value, which is the variable that we talked earlier, with a normal distribution, which is I provided the graph earlier as well. The average is 0.07472. The standard deviation is 0.03745, and I took 40 random sample from the population. So what is the probability that the sample mean is between 0.07 and 0.084? So we have the answer here. So right here I have the data that is needed to answer the question to be input into the formula. So we have that z value equals to x minus by mu divided by standard deviation divided by the number of sample, the root of the number of sample, and the z value that I got is minus 0.797114. Due to the z value, we can find the probability, which is p. The mean is more than 0.07 equals to 0.08 0.78731, and then we're going to count the standard error of the mean. So the standard error of the mean is going to measure how much like error in this sample that we took. and I got the standard error of the mean is 0.01, and I also provide the graph as you can see below the formula. And then we jump into the confidence interval. A confidence interval is a range of values that describes the uncertainty surrounding an estimate. It is made using a model of how sampling, interviewing, measuring, and modeling contribute to uncertainty about the relation between the true value of the quantity we are estimating and our estimate of the value. And I also provide the general formula, which is point estimate plus or subtract by the critical value times standard error. And here I also provide the examples of the confidence interval. As you can see, with the level of 95%, so this is what it almost looks like. And the z value will be from the left side and the right side will be each minus 1.96 and 1.96 on the right side. So the left side is minus and the left side is negative and the right side is positive. And the point estimate is in mil between those two. And I also provide the critical value in certain confidence level. So for example, if we use confidence level of 80% and the z value will be 1.28, and yeah, if we do an interval, then on the left side it's going to be negative 1.28. And in this case, we're using confidence level of 95%. So the z value is going to be 1.96. So here I'm going to use the volume variable, the volume value for the confidence interval. So from the volume data, I got the mean is 55,526.5, and the standard deviation is 4,358.1811607, and the number of sample that I took is 40, and I'm using a 95% of confidence level. So the confidence interval, so we're going to count the confidence interval now using the formula of the previous, which is point of estimate, um, add or subtract it by the critical value and the standard error, and then we do the process. And as you can see, actually the critical value times by the standard error is actually equals to margin of error. So that's why this value is the margin of error. So this value uh, decides whether it will be add or be subtract by this number. So with 95% confidence level, we have the confidence interval, which is 45,175.886, and the right side is going to be 56,877.114. And here is the graph of the volume confidence interval graph, which is, as we can see here, on the left side we have the 54,001, and then on the right side we have the 56,000. So this is actually the point, the value, and it is different with the critical value, which is always going to be negative and positive. The next, we're going to do the hypothesis testing. So for hypothesis testing, we're going to provide the null hypothesis, and we're going to also provide the alternative hypothesis. So for the goal of this testing is to reject the hypothesis, whether it's the null or the alternative. So first we're going to reject the null, and if it's not rejected, we're going to continue to try reject the alternative. So first, we're going to try reject the null. For example, I take the mu value here equals to 60,000. So first, I want to find the critical value or the z value, which shows I'm using the same formula as before. The mean subtracted by the value that I picked, and then divided by the standard deviation of the sample, and then divided by the root of the sample itself. And then I got the z value, which is minus 6.4919. So here I'm using the 95% confidence level. So the z alpha value is going to be 1.696, which is according to this table right here. If you use 95% of confidence level, the z value is going to be 1.96. And here, so the condition here, if we're going to reject, so if the z value satisfy the z less or equal to minus z alpha, or z more than or equals to z alpha, that means that the current hypothesis that we're analyzing is going to be rejected. So reject if z value that we just found less or equals than to minus 1.96, or z more than or equals to 1.96. So the value that we just found was minus 6.4919 is less than minus 1.96, and that means that the null hypothesis is rejected. And that is the end of the testing because we already reject the first hypothesis. And next we're going to move on to the correlation analysis. The correlation analysis uh, examines the linear relationship of variables. For example, in this case, I'm going to take a random case. Is there any connection between how fast a person learns a certain instrument to their success debut in music performance? So the answer is, if the correlation analysis show any relation between two characteristics, then it can be investigated whether one variable can be used to predict the other. So it has some correlation analysis, which is actually logical if you think it in a logic way. And then we move on to we're going to talk about the correlation analysis in more in depth. In depth, the correlation analysis uh, it examines the linear relationship of variables. The strength of the correlation is determined by the correlation coefficient, which is varies from -1 to 1. So as you can see here, there's like a table which indicates whether the strength of each correlation. So for example, if the number is from 0 to 0.1, there is no correlation. If 0.1 to 0.3, there's a little correlation. From 0.3 to 0.5, there's a medium correlation. From 0.5 to 0.7, there's a high correlation. And from 0.7 to 1, there's a very high correlation. And there's also direction of correlation. So positive correlation is present when larger values of variable A is accompanied by larger values of variable B. And the negative correlation is present when larger values of variable A is accompanied by smaller values of variable B. And here I already got the value of my correlation coefficient, which is from both of the value, which is the high value and the volume value from the filtered data. So according to the table as before, the correlation, there's a high correlation between both of the variables, which is the high variable and the volume variable. And I also provide the scatter diagram. And as you can see that the um, that each dot is just like connect to each other, and the more condensed they are in one area, uh, the higher R value it is in the correlation analysis. And next, we're going to talk about regression analysis. A regression analysis makes it possible to infer or predict another variable on the basis of one or more variables. An example, is there any correlation between how fast a person learns a certain instrument to their success debut in music performance? The answer is, since the correlation was between both of the variables, then how fast a person learns a certain instrument variable can be used to predict or infer the success debut in music performance variable. So this says that the data of like how a certain person can learn a certain instrument can so the data itself can be used to predict whether they will be successful or not in their upcoming debut in music performance or something like that. So here I have the calculation, which is the y equals to b0 plus b1x. So the x is actually a variable, and it will be, yeah, it has so many values, so you cannot really finish it, and we cannot get like a certain nominal number. So the result of this calculation is actually going to be a function, which has a x variable in it. So here is the formula of regression analysis, and all the way down, this is how you count b1 and b0, and this is the mean from before, and this is also the mean from the x value was the high, so the high, this is the mean of the high value, and this is the mean of the volume value. And here we have the square of r, which is 0.3061, and we're going to use it here. And then here I have the equation of the regression line, which is minus 17,975.9003 plus 966,362.819x. So the variable x here is actually based on the below of here, as you can see. So we have to chart it with the line fit plot and the residual plot. And yeah, so we're using this function to get the the dot that here. So yeah, it's like a scatter diagram, but it has this equation which is we get from the previous formula. And also we have the regression ANOVA, as you can see here. And then I have more description about the regression analysis as well. So the first one is y and x relationship to r squared equals to 0.3061. It means that 30.6% of the variability of y is explained by x. So it is the same as before when I used the simple case, that the ability of a certain person can play a certain how fast a certain play person can play a certain instrument can actually, the data itself, we can use it to predict whether they will be successful in the upcoming debut and music performance or not. And the correlation or the R value equals to 0.5533. It means that there is a moderate direct relationship between x and y. So there's actually a table as well for the regression analysis. So if the value is 0.5533, it means there's a moderate direct relationship. And the second, I'm going to talk about the goodness of it. So overall regression right-tailed is as follows. And then as we discussed it before, we reject the null hypothesis, and we have the linear regression model. Here we have the slope, which is two-tailed, and then we have the y-intercept. And hence b is not significantly different from 0. It is still most likely recommended not to force b to be 0. And I think that's all I can present to you about my statistics final project. I hope that my material can be received easily by you. And thank you for your attention. Thank you for listening and have a good day.